Hello everyone, my name's Anna. I'm going to be doing the grade 11 functions units from the Ontario curriculum. There are going to be a total of 6 units that we're going to do. We're going to be starting with quadratic functions, which is typically the second unit. I think it makes more sense as unit 1, so we will be reviewing quadratics first. A lot of this is review from the grade 10 course. However, a lot of times people have forgotten about it, or we're not as comfortable with doing it as we'd like to be. And so this is a topic that comes up again in grade 11, and that's why we're going to start with it. Here's the different topics we're going to be discussing throughout this quadratics functions unit. Now, today we're just going to focus on the day 1 topics of solving quadratic equations by factoring, but you can take a quick look at all the other days as there are many other topics that we will cover in this course. All right, well, let's go ahead and get into it. So, first of all, when we're solving quadratic equations by factoring, we need to use the zero product property, right? So the zero product property, it's right here. It states that if A times B equals 0, then either A is equal to 0 or B is equal to 0, right? Or in simpler terms, if we're multiplying two numbers together and we want to know, well, in what circumstances will multiplying those two numbers together get a 0? Well, simple. It will be 0 if either one of those numbers is 0. So if A is 0, then 0 times B is just 0. Regardless of what B is, we really don't care what B is. Or if B is 0, then it's also 0, right? 0 times A is just 0 again, regardless of what A is, right? So we don't care. So all we care about is one of either A or B 0? And likewise, there's no other scenario, right? Is there any possible way to have an A and B that are both non-zero and yet we still get 0 as our answer? No, there's no possible way. Now, one could argue that we could get really, really close. Maybe if we had A is 1 and B is 1 over a trillion or something, you could argue that's really, really, really close to 0. But the only way to get exactly 0 is for either A to be 0 or B to be 0 or both potentially. Okay, so that's the idea of the zero product property, that if we multiply two numbers together and one of them is 0, then the product is also 0. So we can use that to solve this equation. We can say, here they're saying x minus 5 times x plus 2 is 0. Well, let's say that x minus 5, let's treat this like A, and let's treat the x plus 2 like B. Well, if x minus 5 is equal to 0, then the whole thing is equal to 0, right? So that means if x is equal to 5, then that means that the whole equation is 0. And let's try it. Let's plug it in. If we plug in 5 minus 5, we get 0. And then if we plug in 5 for the other x, we get 7, right? We get 0 times 7 equals 0. Is that true? Well, yes, of course it's true. 0 times anything is 0. Now, what about the x plus 2? Same kind of thing. We need to set x plus 2 equal to 0, and from there set x equal to negative 2, right? Because again, in that case, b would be 0, and so b times whatever a is, I think it's negative 7, but that's neither here nor there. We're going to end up with 0. And this is a common technique. This is why sometimes factoring is a great way of solving, because when we factor, sometimes it's very obvious and we can really tell very simply and very easily, oh, these are our answers. These are the things we're going to use to solve. Let's try another example here. Solving quadratic equations. So here it tells us that to solve a quadratic equation means to find x values for some y value. The first step to solving a quadratic equation by factoring is to determine which type of factoring to use. And I think this is the hard part for a lot of students when it comes to factoring, because there's so many factoring methods. There's common factoring, there's decomposition, factor by grouping, there's certain rules for perfect squares, there's certain rules for difference of squares. So what do we use? So for this example here, I can tell it's a difference of squares, right? 9x squared is a perfect square, as is 16. So recall the rule, recall that if we have a difference of squares, so a squared minus b squared, that this is equal to a minus b, a plus b, right? This is a general rule. So whenever we have two squares and a negative sign in between them, that's a difference of squares by definition, and we can use this method to factor, and it will work every time. So for example here, let's see, the square root of 9x squared is 3x, so our a value would be, our a value would be 3x, and our b value would be 4, right? Because the square root of 9x squared is 3x. The square root of 16 is 4, right? And it's a difference of squares. You might say, oh, isn't this negative 16? Well, it is, but this negative is the same as this negative here. So we don't have to worry about that. It's already been accounted for. Okay, so let's do it. 3x plus 4 and 3x minus 4 equals to 0. Now we factored it, but it doesn't just say to factor, it says to solve. So I'm going to go through the solving step where we set both of these equal to 0, and we see what answers we get. So let's see, 3x is equal to negative 4, so x is equal to negative 4 over 3. And then here we have 3x is equal to positive 4, and x is equal to 4 over 3. So we have these two as our answers. Very good. All right. And we can use this not just for this difference of squares, for any difference of squares, we can use this method and find the solution this way if we wish. Okay, let's move on to a word problem. Here it says, the height of an air balloon is given by the equation h equals x squared plus 7x minus 30, where x is the time in seconds and h is the height in meters. At what time does the hot air balloon hit the ground? Well, let's think about that. What are they really asking us? If they want to know what time does the hot air balloon hit the ground, what they want to know is what time, right? What value for x is the height going to be 0, right? Because if we have a balloon, a hot air balloon, and it goes up and then it hits the ground, when it hits the ground, the height is then 0, right? So what we want to solve is what they're really saying is solve this answer. Solve for x, right? Solve what is the time in seconds when h is 0, when the height is 0, when that hot air balloon hits the ground. So let's do it. So this one looks like it might be the deal where we solve by doing our grouping. So let's give that a try. Can we think of two numbers that multiply to negative 30 and add up to 7? So one technique I like to tell everyone for this, in this kind of factoring in general, is there's a lot of things that add up to 7 or any given number. But there's only so many things that multiply to negative 30 or any given number, right? If we think about it, every number only has so many factors. In fact, some numbers are prime, and so they only have two factors, one in themselves. Some numbers like 10 have, a couple more factors. So, 1 times 10 and 5 times 2, and then negative 1, negative 10, negative 2, negative 5, right? So, some numbers have a few more factors than that, but there's only so many factors any given number has. Whereas in terms of what can add to a certain number, well, there's so many things. There's so many things. So I like to figure out what are things that multiply to our C value first, and then go back and see, okay, do any of those also happen to add up to 7, right? So let's do that. So with 30, minus 5 times 6 is 30. 5 times negative 6, well, that's also 30. However, neither of those add to 7, so we're out of luck. What else? 3 and 10. Actually, that's probably a better idea now that I think of it. Negative 3 times 10 and 3 times negative 10. Now, it's probably actually going to be this one here because negative 3 plus 10 gives us positive 7, and it's positive 7 we want, not negative 7. If we wanted negative 7, though, we would choose the other choice. But in this case, we want positive 7. So it's important to get the signs correct. Now, I know there are more factors of negative 30 that we could get into, like 1 and 30 and 2 and 15 and things like that. I'm not going to get into that, though, because we found the solution we're looking for, so we no longer care about finding more factors. So let's do that. We chose numbers negative 3 and positive 10. So x minus 3 and x plus 10. And we could expand this, and if you expand this, we'll see that we do get the top back, right? Because when we're factoring, we're not actually changing the equation, we're just changing the form of the equation. We're keeping the equation the same. We're just manipulating the equation in order to have it show us what we want it to show us. And what we want it to show us is what are the x values, what are the solutions here. So now we're going to use the zero product property again to say that x is equal to 3 or x is equal to negative 10. Now, in this situation, negative 10 for seconds doesn't really make sense because time is the seconds after it's, taken off, after it started, right? And h is our height. And so negative 10 is not applicable. So x equals 3 is our answer. Now, that does seem like an awfully short hot air balloon ride. Hopefully, you'd go there for longer, but this is the answer, right? So then I'm just going to write a quick conclusion statement saying this, that the hot air balloon hits the ground after 3 seconds. The hot air balloon hits the ground after 3 seconds. Very good. All right, and let's move on to the next one. The next one says to solve 6x squared plus 11x plus 10 equals to 20. So based on the fact that this is the solving by factoring, I'm going to solve this by factoring. However, there are other ways to solve this too, and it doesn't really specify. I'm going to solve by factoring, but take that as you will. There are other ways to solve this. So the first thing I'm going to do is I'm going to put everything onto the same side. I'm going to subtract 20 from both sides, so we end up with 6x squared plus 11x minus 10. Now, unfortunately, we can't common factor. One thing I always say is if you can common factor and your goal is to factor fully, then do. Always common factor if you can. However, in this case, we can't common factor because these numbers do not have a greatest common factor that is not 1. Their greatest common factor is 1, unfortunately. So for that reason, we're going to be using the decomposition method and followed by factor by grouping in order to solve this. So 6 times 10, right, our a value times our c value, 6 times negative 10 is negative 60, and our b value is 11. So I would like to find two things that multiply out to negative 60 and add up to 11. And again, I'm going to do the same thing as before, where I find things that multiply to negative 60 first, and then see if they work with negative 11 or with positive 11. So let's do that. Let's see, negative 6 times 10 and 6 times negative 10. Well, unfortunately, those don't work with the 11. Neither of those pairs add up to 11. They add up to 4 and negative 4. So that's a no. Okay, what else? Maybe 12 and 5. Actually, I don't think that'll work, but they do make 60, so I'll write them down now that I thought of them. Okay, what else do we have? Okay, and what else do we have? 4. Would 4 work? Yes, so 4 would work. 4 times what, though? 4 times 15. Yes, and that's it. That's going to work. Okay. So 4 times negative 15 and negative 4 times positive 15. This is what I'll choose because, again, our b value is positive. So negative 4 plus 15 is exactly what we want. Awesome. So let's put that in then. So I'm going to decompose this and say 6x squared minus 4x plus 15x minus 10 is equal to 0. So I took this 11 and I put it into two different categories. I put it into the category of minus 4x plus 15x. So I didn't change the equation. I'm just, splitting this 11 apart. And the reason we did this step is to split it apart in such a way that we can now factor by grouping guaranteed. So I'm going to factor by grouping. I'm going to partial factor the first two, and also partial factor the latter two. So for my first two, 6x squared and minus 4x, the greatest common factor is 2x. So I'll factor out a 2x, and we'll get 3x minus 2. And then for this one, for 15x and negative 10, the greatest common factor is 5, I believe. 5. So 5 times 3x minus 2 equals 0. And now I'm going to common factor out the 3x minus 2 from both places. So we end up with 3x minus 2 times 2x plus 5 equals to 0. And now all I need to do is to use the zero product property, the zero product rule, in order to determine the final answer here. So let's see, 3x minus 2 is equal to 0. So therefore, 3x is equal to 2. Therefore, x is equal to 2/3. And over here, 2x plus 5 equals to 0. So therefore, 2x is equal to negative 5. X is equal to negative 5 over 2. So those are our final answers. Those are the final solutions. All right, there's one more for today, and then after that, I'll give some homeworks and some suggested questions for you guys to work on, and then we'll see you in the next lesson. Okay, so here's one last example. It says the height of a flying squirrel is given by this equation, where x is the time in seconds and h is the height in meters. When is the squirrel at height of 2 meters? Okay, so when is the squirrel at a height of 2 meters? Pretty straightforward. We just plug in 2 for h. So 2 is equal to negative 4x squared plus 18x minus 6. Good. Then I'm going to subtract 2 from both sides, like that. And then I'm going to common factor, because we can common factor out a 2 here, I guess a negative 2 here. So I'm going to common factor first. And now I'm going to use decomposition, followed by factor by grouping, followed by just zero product property. So very similar to the question we did previously. So I need to find two numbers that multiply to 8, right? Because 2 times 4, right? 2 times 4 gives us 8, and that add up to negative 9. So let's see. 8 could be negative 2 times negative 4, but and that's not going to work. That only adds up to negative 6. Oh, negative 1 times negative 8, of course. That's going to be our answer. All right, so let's do that. So 2x squared minus 1x minus 8x plus 4. I put this backwards, sorry. I'm realizing I should have said negative 8x minus 1x plus 4. And then it's going to be the same proportions, right? The whole point of this is to have the same proportions so that you can factor by grouping afterwards. So let's do that. Negative 2. And then here I'm going to common factor the first two terms and common factor the second two. So our greatest common factor from 2x squared and 8x is going to be 2x. So 2x times x minus 4. And then minus x minus 4, like that. And keep in mind with this minus x minus 4, there is an invisible 1 here, right? A 1 minus 1 times x plus 4. And if there was just a plus there, it would be an invisible, there'd still be an invisible 1, an invisible positive 1. So that's very important. Sometimes people see the negative and think, oh, you know, what's that? There's an invisible 1 there. Okay, so now I'm going to common factor out our x minus 4 and our 2x minus 1. And there we go. Voila. And now to solve, to finish this off, we need x minus 4 to equal 0 or 2x minus 1 to equal 0. So therefore, x must either be 4 or x must be 1/2. Those are the options. So therefore, to answer the question, the squirrel is at a height of 2 meters after 1/2 a second and after 4 seconds. So it occurs twice. So I'm going to include both of these as the answers. So therefore, the squirrel is at a height of 2 meters at 4 seconds and 0.5 seconds. And there's our answer. All right, so that's all I have for you guys today. I do encourage you guys to practice on your own. So, from the Nelson textbook, and if you don't have a copy, you can get some free copies from the school. You can complete the assigned questions from the handout. The rest of these textbook pages, just to let everyone know, they're from the Nelson 11 textbook. So I do strongly recommend doing some more practice at this, and we will see you for the next day. Bye for now.